philosophy. Network architecture. I see some of you have already completed the assignments for this lesson. That's good. And we were somewhere. I remember this diagram where you have this hierarchical design where we have access layer, distribution layer, and core layer. So I hope you all are reading the chapter as well, not just looking at the slides and doing the assignments. Because we can complete the assignments. There is no challenge in doing assignments here. There is a lot of helps available online for quizzes, but that will not give you the complete knowledge. Now, if you look at this design, in this design you can see there are racks. Okay. Have you seen the rack in this room? In the room back of this classroom. So, what vendors or the different service providers are doing, they are supplying equipments to the consumers or to different companies previously fitted or pre-fitted in the racks. Okay. There you can see you have servers, you have various devices already fitted in this rack, and switch is also provided, or a switch which is connecting all the equipments of these racks to the main network. So that is kind of top of the rack switch. Top of the rack switch. So every rack has a separate switch available, and there can be single switch. There obviously if it is a single switch, then it won't serve the purpose. It's mostly there are two switches always. And what is the reason of having two switches? Huh? Two networks. Redundancy. Anyone else? Nigel?
Latency? Is that part of it?
Latency? No. Redundancy is the part of it, or we can say failover protection. So if one device fails, there is another device available, right? If one device fails, then there is another device available for backup or for replacing the failed device. So we always have, like, we have two switches here. In this design also you have two switches on top, and you can see every switch here is connected to both the switches. So if one switch fails here, then also the device or the rack still has the connectivity with rest of the network. So in all kinds of IT design, wherever you have a mission critical, Mr. Said.
Yes.
Paying attention here is more important than recording the lecture. Okay?
Yes, sir.
Okay, so where I was. So redundancy is always required to avoid any kind of single point of failure. Okay, and if you can do that, or all kinds of design is not just the network design. If you look at the servers, if you look at the storage devices, if you look at the high-end configuration setup, or even the power supply, even the cooling equipments, whatever all these devices we are using in a data center kind of a setup, it's always set up in a redundant mode, so that if one device fails, then there is another device available. Our home network is not that critical, so we do not use redundant components there. Even I would say this college network is not that critical. If the college network fails, then no mission critical, or there is no life in danger, or there is no big data loss, or there is no big transactional loss happen if this fails. So looking at the criticality of the operation, we decide whether we will go for a redundancy or we won't. It's not that in every network we must have redundant component. No, it's not like that. You always calculate the loss versus investment. How much loss we may incur or we may have if I do not have that service. First you need to shift the box, and then only you can either side. Yeah, shift it, go more left if it's possible. Yeah, now move the monitor. No, put it down. Move it.
Yeah, it's like really tied
Twist.
together.
Just turn the face a little bit. No, not that way. This way. Yeah, and now move. Yeah.
Well, now I can't see it at all though. Oh.
You may. Better? All right. So we always do a analysis, and this analysis is required at every level. It's not that. So starting from the top, which is basically power supply, to the infrastructure, including the security devices in the infrastructure, including the servers or the computing, then storage. Everywhere we will look at the single point of failure. What is my single point of failure? And we look at the impact of that device failure in rest of the network or rest of the infrastructure, and decide whether this device is a critical device or it is just another device. Failure of that device will have no impact on rest of the infrastructure, so I don't need to pay attention towards it. Otherwise, we always look for redundancy. Okay, so this is what architects do in the network. So in order to do this, what is our objective or the advantages is improved redundancy, decreased latency, increased performance, improved scalability, increased security, and reduced expense. If I say improve redundancy, you are using multiple devices in the network, so redundancy improved, so that means the single point of failure is removed from the network or from the infrastructure. Decreased latency while you are using multiple devices, there, so in that case the congestion will be lesser, and when the less congestion, then your devices will get more bandwidth to communicate with each other, so there will be decreased latency. Obviously, when there is a lower latency, the performance will automatically go up, and there you are using redundant devices, so multiple devices are working together. They are creating a pool of devices instead of one single device, so the performance will improve. Improved scalability, you can scale up or scale down your network. Now, for the scalability, is there any kind of infection in this room? I see a lot of sneezes since we started the class.
No, sir.
Okay. The improved scalability. What is scalable? Scalable is like, if I ask, is this room scalable? The answer is no. This room is not scalable. Whatever the size of that room is, this is fixed. If I want to increase the size of that room, I need to break a wall and then extend the room on one side, either on that side or that side. If I want to add more computers in this room, do I have space to add more computers in this room? The answer is no. We don't have more space to add computers in this room. So we need to find out a way so that we can increase the number of components in my network whenever the need arises. So when you are planning for a data center, when you are planning for a network center like that, so you should always look for the scalable. Is this setup scalable? Is this setup scalable? If yes, then you are safe for future expansion. If no, then you have to find another place in future when you are planning for add more devices. when your business starts growing, you have to find more space. People are saying that some big giant companies, they started out of garage, right? Or in the basement, like Facebook or Microsoft or whatever. They started out of garage or basement. Are they still operating in the garage or basement? No, obviously not, right? So we need to look at the scalability, and we need to find out or look for the space. Increased security, when you are using multiple or this type of hierarchical design, your security will go up because of multiple devices are working together, and obviously expense is reduced. Why expense is reduced? Because you will not spend a lot of time and amount in replacing or taking care of those devices, because your design is robust, because your design is fail protected or failure protected from any kind of failure. Look at this network availability and redundancy topic here, and when I say everything has to be highly redundant, now that's again I'm repeating my statement that it's not every network has to be redundant, or every device in the network need not to be redundant. It depends on what is the criticality of that network, or what is the importance of that device in the network. If one particular Wi-Fi router or this Wi-Fi extender fails, will it impact your network? Will it impact your overall network? Answer, please.
If there's only one, then yeah.
If it is only one, then yes. But in this room or in this building, if one device fails, then will it impact? No, it won't, because we have multiple others running. So these are not that critical. But if there is a switch in this building and there is only one switch in the building and that switch fails, what will happen? Huh? The whole building is not having any network. It's disconnected from rest of the campus. Will have a problem, right? So that's how we decide what is critical and what is not. Someone has any question here?
Okay, so in like your average home network, what
Yeah.
would be the biggest single point of failure? Like if you were gonna add one redundant device, like what would you usually want to add in a home?
Answer yourself, first of all. In your home network, what is one device? If that device fails, your whole network is down. Router. That is the router. But do you have multiple incoming connections in those routers?
Probably
No.
not. Only have
So you have just Xfinity in your home. So how many wires are coming in your house from Xfinity? One. If that fails, if someone cut that wire from outside, will you have network? No. So all the security devices in your house will be disconnected.
so
Will be disconnected. Is the answer yes or no? Yes. Answer is yes. So what do you need? You need multiple internet connections. But if all the internet connections are wired, then how those internet connections are protected?
there's one wire. There's only one wire then.
There is only one wire. There is only one cable supply in your network, in your house, and that cable supply is damaged, then you don't have any supply. Even if you are having 2 routers, 4 routers in your home, that doesn't help, because you have just one connection. So you need multiple connections. You need multiple connections. Isn't it?
So getting multiple connections. So what if you had 2 connections in one router? Would that help your uptime?
2 connections, 1 router will again have router as your single point of failure.
Would that be better? Like would that have more uptime than 1 connection in one router? Or no?
No. Obviously, if you have just one of any kind, like let's say it's not about internet device or router. If you have just one device or one supply, and that supply is, so that supply will always be a single point of failure. Because if I see the word single point of failure, so if I have a single point of failure in my infrastructure, and it is going to triple the whole infrastructure, then that is very critical. Let's say you may say that, oh, I cannot have any other second one. So you then in that case, you must have such a reliable service provider which is not going to cut your cable or not going miss that the service provider itself not going down any time in future, so that you can rely on it 100%. If they are providing let's say iron casing to the cables going in your house so that no one can cut that cable by simple cutter. All those things we need to look at the importance of the service which I am having and dependency of that service on the other services. Dependency of that service on the other services, right? How they are connected. So in this network availability and redundancy, we talk about that, but this topic is too wide. We can't just finish talking about these topics in one day. So availability, how do you define availability? What is availability for you? So the moment I open my computer, I should have network in my computer all the time. That's what availability is. If I open the website of any service like bank or Gwinnett dashboard, that service must be available on the browser all the time. That's what availability is. Now Gwinnett Tech says, hey, our services will be available to you from 4 a.m. in the morning till 12 midnight. So starting from 12 midnight to 4 a.m. in the morning, service won't be available. If you are using the service in this time, it is expected that you will not have the service. So what is this called? This is called service level agreement. That the service provider has defined in what time period service is available or not available. So if you are trying to access the service out of the service hours, you will not get the service. Isn't it? So you have to find out what is my availability or what is the availability of the service. If you are a service provider, then you have to ensure that I will provide the service during those service hours. If you are the consumer, you will be using the service only during the service hours. So availability refers to how consistently and reliably a file or system can be accessed. If you see, there are certain services provided in the city by the city administration which are 24/7, right? But certain are not. Bank, online banking is available 24/7 or certain hours. Online banking 24/7. But can I walk into a branch 24/7? No. So that's what availability means. Availability doesn't mean that 24/7. Availability all depends on what is your service level agreement. Defined, well defined in this, and then only you can say it is available or not available. Then you have something called high availability or HA. Refers to a system that functions reliably nearly all the time. There is a one word very important in this entire statement. Can you guess what that word is? Say it loud. Nearly. Nearly is the most important word in this statement. When you say nearly, you are not promising 100%. You are saying 99%, 99.9%, 99.99%. You are leaving a space. You are not saying that I'm going, my disinfectant spray is going to kill 100% germs. They never claim that. Or the hand soap doesn't claim that it is going to kill 100% germs out of your hand. They always say 99.99%. They always leave a space. Now if I say, how much is the 99%? So we have a slide in the coming year. coming up, which gives you an idea what is 99% means. Okay, so nearly available all the time. So that is what service level agreement is. Uptime is the duration of time a system functions normally between failures. So what is uptime? So your system is started now. So it is running and failed at this time. This is uptime. These terms, if you remember these terms now, this will benefit you in your entire career if you are going to have the career in IT only. So uptime is on a computer running Linux or Unix view the uptime by using command uptime. On Windows system, uptime is found in the task manager. So these are basically telling you where you can find how long the system is running. Right? If you have a phone, sometimes phone gives you a report. What was your usage? What was your usage of this phone during this week, or how during the day? How many minutes or how many hours your phone was in your hand, or you were scrolling something, or you were viewing something? That was not the uptime. That was usage time. Uptime means when you power on the system and the system is continuously running. Yes, Nigel.
Where does it say the uptime in Task Manager?
Huh?
Where, or how do you see that in Task Manager?
I'll show you. Okay. All right. Thanks. Thanks, Richard. Right. So network availability. Now, fault tolerance. What is fault tolerance? Fault tolerance is the capacity of a system to continue performing despite unexpected hardware or software malfunction. So, are these systems fault tolerant? Are these systems fault tolerant? So, answer is simply no. These systems are not fault tolerant because these systems has everything single power supply, single power unit inside the cabinet, single CPU, single motherboard, single hard drive, single RAM, single monitor. These systems are not fault tolerant. Okay? So you need to look at the system which is fault tolerant so that you can. Now, what is the purpose of having a system which is fault tolerant? If the system is fault tolerant, then I can say the system is reliable. Is our body, which part of our body is fault tolerant?
Whole thing.
Huh?
Whole thing. I said the whole thing.
Whole thing.
Yeah, lots of stuff. I mean, you don't just die every second. You can stay alive for like a long time, and you don't just like drop dead if you forget to eat food or forget to drink or whatever.
You have a single brain. You have a single heart.
Yeah, but like a lot of stuff can happen to your brain, and you still live.
See, this is not the way systems work, right? Can you say that this person who's lying in the bed, considered brain dead, is a functioning person? No, you can't. That person is of no use. So fault tolerance is what the system is the component which is reliable. If I say I can still use it. Your car, how many engines your car has? Just one. Right? How many tires we have in our car? 4. Can I run my car on 3 tires? That's not the running. You can't run it forever. Right? So see, we need to look at the system the way they are designed to provide a service. How the system is, or what type of service the system is designed to provide, and what is the level of fault tolerant the system should be able to survive. So that is your fault tolerance, which is the capacity of system to continue performing even if one component or multiple components failed in that system. So if you imagine the servers, the computer servers, they have multiple power supplies, they have multiple CPUs, they have multiple hard drives, They have multiple memory chips, or the RAM, which is known as RAM. So they have multiple components. Why they have multiple components? Because those servers are running critical services. Those servers are running critical or mission critical operations. We can't survive if that server fails. So that's why. But again, there is always a limit of redundancy. You can say, what if both the component fails? Okay, let's add third one. What if third one is also failed? Let's add a fourth one. Can you keep on doing that? You can't do that. You can't keep on adding components as a redundant one, because everything has a cost and everything needs a space. You can't add your power supply in virtual environment. Can your power supply be virtual? No. So that means it needs a space, it needs a cost, and there is always a limit for that. So what is failure then? Failure is a deviation from a specified system performance level for a given period, given time period. Now, these are the terms which you will study keep on studying in your future lessons or classes. So we look at them very carefully. Failure is a deviation. So if the system is not able to perform what it is designed for, then only we say it is failed. Then we say it is failed, right? If I power on this system and the Windows operating system doesn't start, then I can say, oh yeah, the system is failed. If the system is running, but you say that, oh, this system is not playing movie for me. Is the system designed to play movie? No, the system is not designed to play movie. The system is designed to run a dashboard application. Are you able to run the dashboard application? Yes, I am able. But my expectation is movie. That's not what you're expecting. It's not based on. Your systems are not based on what your expectation is. There is always a service level agreement. There is always a service. So everything is designed according to a service level agreement. So whenever you say whether it is running or not running, whenever a customer is complaining, hey, oh, your bank branch was not open when I visited it at 6 o'clock in the evening. Sorry, the bank is not supposed to be open at 6 o'clock. Oh, I was not supposed to, this supposed to be open all the time. No, it is written in the service level agreement. So everything is designed according to the service. So whenever you are planning to set up an environment or providing a service, the first thing you do is service level agreement. And based on that service level agreement, you design and set up and prepare and run your services and infrastructure. What is fault? Fault is a malfunction of one system component. It's not the one, that component can cause the entire system failure, and that component may be just one component, but the rest of the system is still running. You have two power supply units in a server, one is running, one is failed. One is running, one is failed. So the system is not yet failed, service is still running, but your component failed. So you can just replace the component and continue. So the goal of a fault tolerant system is to prevent faults from progressing to failures. It's a very important statement. Why we are having fault tolerant? And now, how can I get fault tolerant system? How can I have a fault tolerant system? We can have a fault tolerant system by having redundant component in the system. Now, redundant component can work in two ways. One is called active passive, another one is called active active. When we are using active passive component or active passive setup, we are running at 100% and 0%. When we say active active, we are running at 50-50. We are running at 50-50, right? Why 50-50? Yes, say it. Why 50-50?
Just 50% on each device.
Say it.
50% on each device.
What is 50%? Because you are not paying attention. I don't know where you are busy. What is more important than the class? Okay? Alright. So my point is active, passive, 100%, 0%, active, 50-50. Right? And you know what is why 50-50? Why not 100-100?
They're both on, so it's like splitting the load between them.
Right?
Exactly.
You were saying something?
I guess I was saying something like that.
Huh?
I guess I was just saying like split between the devices.
Split, why we say it is running 100 and 0, but it is running 50-50. If I run 100 and 100, will I get more?
Well, that doesn't make any sense. It can't be both 100.
Why? They both are active. Why they can't be both 100?
That's not 100. If they're 100 would be one's off.
See, this is one system. This is one complete system. Okay? This is one complete system. And what is the performance of one complete system?
100%.
100%. So it has to be divided equally, and the total of both the devices must be 100%. If I say this one is running 100, this one is also running 100, and this one failed, so can this one take the load of 200%?
No.
No. What is the maximum capacity of any system? 100%. Percent is always 100. Whenever we say that 200%, we say that it is a gain. It is a profit. But in this system, we do not run these systems for profit. So these systems cannot run for 200%. The total of the systems can only be 100%. So remember that redundant components always run in two ways. One is active passive, another one is active active. Active active runs 50-50, active passive runs 100-0. Okay? So that is the goal. The last line here, the goal of a fault tolerant system is to prevent faults from progressing to failures. And how can I achieve a fault tolerant system? By having redundant components, by having active active or active passive components in my system. Some devices, remember, some devices can have more than one or more than two units. For example, a server unit can have 5 power supplies. A server can have, or one server unit can have 5 power supply units, PSUs. Now, out of 5 power supply units, they can run active passive in 3+2, 4+1 configuration. 3 active, 2 passive, 4 active, 1 passive. Or we can have all active. And whenever we say all active, remember it is not going to run at 100%. Now out of all active, again it is server's internal mechanism designed in such a way that it will use some of the devices, it will use 100%, not 100% even. Some of the devices it is using at 60%, rest of the two it is using at 10%, and one which is left is using whatever is left, 20%. So system itself can decide how it is going to use those active devices, at what percent levels it is going to use those devices. But we always have this kind of a setup. Okay, so even if I have more than 2, it's not just 2 only. If I have more than 2, then how the system is going to use them? It is going to create a combination. If I have 6, then you can say it could be 3+3, it could be 4+2, it could be 5+1, But can it be 2 plus 4? Active passive. Which combination seems invalid or impractical?
Maybe the 2 plus 4.
2 plus 4. This cannot be a combination.
What about 4 plus 2?
It's written there.
Or 5 plus 1?
It's written there. Okay, sir?
Yes, sir.
Wait, why is the 2 plus 4 not?
Tell me. Yours.
Is it just not enough power? Is that it?
It's not. It will not give you enough power. Not only that, but it's a complete waste of money.
Oh,
You can't have 1 plus 5 either.
No. Right now, even if in that case, these type of, whenever we say that we have a redundant power supply, like 6 PSUs are there, so these PSUs, each individual PSU is designed in such a way that it alone cannot run the whole device. Alone it cannot run the whole device. So there is always a minimum. How much is minimum safe device requirement? So it always says that what is the minimum requirement to run that device. Now these type of high-end servers, when I talk about the high-end servers, so they have different performance levels. So they can run at 60% level, they can run at 70%, 80% or 100%. Now in order to run these servers at different performance levels, how much power is required by that server? And in order to provide that power, how many power supply units are required? So it's all defined, it's all given, and based on that, it is calculated how many units are required and how many units should be active and how many units minimum can be or maximum can be passive and how many minimum has to be active. How many minimum has to be active and how many maximum can be passive. You can't say that I will use only 2, I will save more. I will save more if I use only 2. But you can use 2, but in that case your server will be running at 40%. Is that acceptable? 40% performance only? No. You are investing a lot of money in buying that server, but you are not using it at full capacity. It's up to you. Okay. So there are many things associated with that. It's not that we can, why I can't use 2 plus 4? Oh yes, you can, but in that case your server won't be running. Or you can't run all the servers, you can't run all the components, you can't run the server at maximum performance level. Okay, redundant links. So we always try to establish multiple links. So in our case, in normal scenario, our computers, our laptops, our phones, they all have single connection. They all have single connection. But in our phones, we have 2. We have 2 types of connections in our phones usually. Either we can connect to Wi-Fi or we can connect to the service provider. If Wi-Fi is not working fine, we can jump to the service provider's data network or we can keep switching. But again, how many receivers are there in your phone? Just one. There is a one receiver or there is a one unit with one component which is connecting to the Wi-Fi or connecting to the service provider. If that one component fails, can I connect my phone to the Wi-Fi? No. Same as with these devices. If I have just one NIC in my device, if that NIC is failed, can I connect to the network? Answer is no. There is only one cable coming into my house for internet. If someone cut that cable, can I get the internet? No.
Okay, if your phone only has one NIC, and let's say you're connected to Wi-Fi and you're connected to data, is that going to give you, does that just basically give you no benefit, or is there still some benefit from that?
You have just one. Either you can connect to Wi-Fi or you can connect to data network.
Okay.
We can't connect both the networks simultaneously. What happened, David? Put it down. I can't connect both the networks simultaneously. If I have 2 parallel networks connected simultaneously, then I can speed up my bandwidth.
Oh.
I can speed up my bandwidth. I can, if one network is down, I have another network available. I can keep on running. But is that happen? If let's say my phone is connected to Wi-Fi and for some reason Wi-Fi is not working or Wi-Fi has no internet, can you still get the data on your phone?
Yes.
No, your phone does not automatically switch from Wi-Fi to data network. You have to turn off your Wi-Fi, then only it goes to your data network. Have you tried that? Just try it. You don't have a Wi-Fi. How can you stop internet on this Wi-Fi, Nigel? How can you stop internet on this Wi-Fi?
I can turn off my Wi-Fi on my
No,
phone.
I'm not saying. See, listen to me very carefully. Your phone is connected to Wi-Fi, but Wi-Fi has no internet.
Um,
Your phone is connected to Wi-Fi. Wi-Fi is live. Wi-Fi is live, but Wi-Fi has no internet. From the back end, Wi-Fi is not getting internet. But your phone is connected to Wi-Fi.
so I have to turn the Wi-Fi off and connect to data.
Then you have to turn off your Wi-Fi and connect to data so that you continue getting your internet. So you are switching.
So you can't do that.
If I have, let's say I have two internet connections coming to my house. This is internet, this is internet. This is AT&T, this is Infinity or Xfinity. These two internet connections coming to my house. What should I, if my device is connected to AT&T and AT&T stop working for some reason, what I need to do to shift to AT&T or to Xfinity? I need to change my connection over here, isn't it? But if I'm using this kind of a setup, then I can use some kind of device in between, and that device is known as load balancer. Load balancer. What this load balancer does, it keeps on having connection, goes into the load balancer, and your device getting connection from the load balancer. Now this load balancer is taking care of your network. If your network is coming from AT&T, you are getting it from AT&T. You can set up which one is primary and which one is backup. Okay, so load balancer knows that AT&T is primary and this one is backup. Until you are getting connection or internet from AT&T, you keep getting it from AT&T. Once AT&T is down, the load balancer will automatically shift to Xfinity. So even if I have two connections, I need some mechanism in place which can shift my operation from one device to other device, from one connection to other connection. So that means, guys, listen very carefully. So that means if my server has two power supply units in my server, let's say server has two power supply units. They both are connected to the mains. This is my mains. So how does, and this one is active, this one is passive. If this active fails, then how does server knows that active is failed, now I need to shift to the passive, or I need to start the passive? So server has a small mechanism or load balancer or a software unit installed in the server running all the time. And every such device which is running in redundant mode, they always send some kind of signal to the controller of the unit, sending signal to the controller, I'm alive, I'm alive, I'm alive. The moment it stops sending signal, the controller knows, oh, this one is down, so I should shift to the second one. I should shift to the second one. So this is every device which is using multiple components need this load balancer kind of device. Every time.
Just like how do power supplies have that too? Or is that just
It is power supply too. Now you may say that if the power supply is down, then how the system get the power? So What is this? What may be the solution if you, let's say the main power supply is failed and you need 5 seconds to shift to the other power supply. So how can you keep your system running for those 5 seconds? Battery. Simple answer is battery. So you need a battery in the system. So does that means these type of servers has a battery as well? Yes, answer is yes. These servers has batteries as well. Getting my point? So why we are doing that? Just to avoid or remove single point of failure. To remove single point of failure. So every time we are asking a question, what if, you are finding answers for that. What if my power supply fails? So I have a second power supply. But if the power supply fails, how the system will get the power until the system switches to the second power supply? Battery. So I have a battery. Now even though, listen, even though the battery is, let's say your power is 110 volt or your system requires 100 watts of power. Your battery may be 50 watts. Battery may give you only 50 watts. So what the server does, servers, they shut down the unimportant or non-critical operations for a while and continue with the critical ones. For example, doctors are doing this induced coma operations these days. They shut down the whole body operations, non-critical operations of the whole body shut down, and they do the operations such as brain surgery or open heart surgery kind of a thing, where they don't want the whole body to function. So systems are doing that. They do not run the whole operations of the system, they just run the critical operations while the system is running on battery.
Oh, is it like random access memory? Like
Yeah.
You don't wanna lose that.
So it is not using the whole power of CPU, it is not using the whole memory, it is not using the hard drive, it is running only saving the important data which is lying in the system. So when you learn more, what is important data in the system, so where the data is pending in the system, can you say? Do you guess where this data is pending in the system? RAM. Where the data is pending in the system? RAM. So RAM is the component which holds the pending data in the system. So if I can protect my RAM, data and the processes which are currently running in my processor, there are some processes running, and the data which is sitting in the RAM, if I can protect these two critical operations and obviously some part of network, my system can survive for 5 seconds. My system can survive for 5 seconds or after 5 seconds. These things are, you will learn more about this when you study more or you ask questions. Ask questions to yourself and ask same questions to some AI tool. You will get the answer. There are a lot of things we have. So you see that. So redundant links, the link aggregation is the seamless combination of multiple. So every time I'm doing some redundancy. Now, when I'm using multiple links, I was talking about this internet thing, and I'm using this load balancer here, and then I'm getting it one. So what the load balancer is doing with these two connections, it is doing link. Now it is kind of presenting my system, it is presenting these two links as one link to my system here. Just imagine. I am getting two connections here, but this device is only giving me one connection. Does this system needs to know whether I am getting internet from this link or that link? The answer is no. This system doesn't need to know. In your body, can you say that if I am looking at that camera, can I say that I am looking from my left eye, not from right eye? If I have two eyes, then why I can't see just one? Why I can't see two?
Load balancing.
It's a load balancer. My mind is working as a load balancer. It is presenting it as one image. Similarly, here, this cable is, this particular device is getting two connections, but it is doing something inside and presenting both the links as one to my system. That's called link aggregation or port aggregation. It is combining two or multiple links into one. It is combining two or multiple into one and giving you, in some cases, your server has two NICs and both the NICs are connected to two switches like this. Now can you tell me how many paths, and these are connected to the internet? Let's say this. Think about this design. Let's say, so tell me, this is your server, okay? Tell me how many paths this server has for internet. How many paths this server has for, someone is saying 4.
I think it's 4.
You are also saying 4. Anyone for 2? Or more than 2? So if you look at this design or look at this structure carefully, you will always say there are 4 paths because 1, 2, 3, 4. 4 paths available. Now, how this system will use, because system cannot use all the paths. System will use one path. Here you are using browser. You open the browser and you open some website here on this browser. How this browser is going to use both? It is not going to use both. It is going to, means system will do this internally. It is going to put them as one. It is going to combine multiple links, multiple devices into one unit, and then it is going to present it to the system, and that is called NIC theming. Port aggregation is what in Linux, and NIC theming is what it is known in Windows. And what is the benefit? Benefit is obviously increased total throughput, automatic failover between the aggregated NICs, load balancing, all these things happens. So these are the very basic things, and you will add up on these when you work in future, like if you go towards the data center kind of things or high-end servers environment, there you will learn more about all these. So this is the diagram where it is trying to show you the link aggregation, and so link aggregation allows two workstations to communicate with the server at the same time. But what do you think that devices communicates with the same? Last week we were talking about something called port. Port? Not in this class, sorry. It was in a different class. But do you know something about port? Port. How many physical cable network you have in your computer? Just one physical cable. In the same physical cable, you can use mail services, you can use internet, you can use internet on Chrome, you can use internet on Edge, you can use it, and you can do some Netflix also, let's say. You can do some Prime as well on the same. So same link for multiple services? How is that possible? How is it possible? Why not your computer get confused with the different services? Because of port. Every service has a port number. Every service has a port number. For example, internet runs on, we say that internet runs on port 80. Okay? We always say that port 80. But port 80 is for the provider, not for the consumer. if my browser is consumer, then my browser will open a different port to communicate with the Google or communicate with any other service. Netflix is an app, so it opens a different port on this same network you have. Prime is Amazon service. It opens a different port. You can check that port. Hmm? You can check those ports. Do you remember? Anyone remembers the command to check the port?
What was the command?
Net scan. A simple command, net scan. Now this is the consumer. I'm local here. See the local address, and this is the foreign address. Foreign means where I'm getting services. From where I'm getting services. On those remote port or the foreign port, I always have HTTPS, 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 HTTPS. These all are same. But here, can you see? Are they same? They all are different. Every time I open a connection or I open a tab or I establish a communication with a server, there is a different port. So every service running in my computer which is using some kind of network service is always opening a new port with that. So this is my service provider which is running on this is the port service, and this is my local port. What is the port for HTTPS? By default, port number for HTTPS is 443. It is default, but these days because everybody knows that that is the port number for HTTPS, so mostly service providers are using different port numbers for their HTTPS. So their HTTPS may be running on some XYZ port number. That's why the port number is not exposed. You see, very rare port number is not exposed means these are the hidden port numbers. These all are the hidden port numbers. Here the port numbers are visible because they are kind of running from some dedicated server. Okay, so these are the things, and everything is virtual here. One network connection is providing me a lot of services. How is that possible? So every time, let's say this person is using this is the server which is providing multiple services. So this person is using banking service, this person is watching Netflix, and this person is playing a game. And they are connected to the same server. So how is that possible that same server is providing different services to all the three? Again, because of the port. So every time one request comes to the server, the same network is connected to all three, so it opens a new port. On the same network, opens a new port. For the second one, opens a new port. For the third one, opens a new port. So one physical connection can have thousands of ports. Now sometimes you notice that company says that the server went down because the number of requests came to the server is more than what server can handle. So that means, or your request is denied. You are getting sometimes during some special occasions, some services are down or not responding in a proper manner. For example, there is a Super Bowl game scheduled, and they said that we are going to open the online booking of tickets on this day, right? On this day, this time. The moment they open, some of you can open the website, but some of you cannot. You are getting server not found, or server is busy. Because the server is not able to open any more port for the new requests. Every time, because there is one server is handling this. Let's say the server is only able to handle 3 requests at a time, only 3 requests at a time. So all 3 are occupied. If a fourth one comes, can he get the connection? No, he won't get the connection. Until 3 are running, he won't get the connection. What I can do is I can add another server here with the same network. So that's what these days we are using virtual scaling of the server infrastructure. They virtually scale up the infrastructure or the number of servers available. What's the time?
Basically, you have to wait till the other person that like bought the tickets or whatever, and then the port would be free then.
Yeah, possible. Okay, it's just 1 hour. You'll take half an hour more and then you'll take a break. Alright, so load balancer is required for that. And sometimes clustering is used. So what I was trying to say here, if I add one more server, so the same that second server has to be running the same service. That server, the second server has to be running same service. And how is that possible? That can only be possible by clustering both the servers together. So there are 2 ways to do the cluster. Again, clustering means running multiple devices for the same service. Can you imagine how many servers there may be for Facebook or Instagram? How many servers there may be for Facebook or Instagram services?
100,000.
Thousands and thousands of servers are running for Facebook and Instagram. How can they still be running same service? Because of clustering. Now at what level they are doing clustering, that is separate. That is a separate discussion. But it's all possible because of clustering. Multiple servers. And there was a time when we were using physical servers to make a cluster. This is cluster. In this cluster, one is always master and others are slave. This is master, these are the slave servers. Master server, slave servers. But these days, we are using virtual. In this case, if I want to add more, I need more physical servers. Can I remove them? Removing is not that easy. But in case of virtual, I can add and remove my servers anytime I want. If I have 10,000 users, let's say these 3 virtual servers, can handle 10,000 users. 10,000 users. If I have one more user comes up, I need one more server. Now this another server can handle 1,000 users. So until this one becomes 1,000, I don't need one more server. If I have another 100 users, then I can add one more server. I can keep doing that. But let's say someday it goes down. It goes down to 1,000. What I will do with these servers? So because these servers are virtual, I can easily shut down them. I can easily shut down these servers as and when required. So this way you can not only saving the performance, you are also saving the cost. This is all happening because of virtualization. So the next topic we have in this lesson is virtualization. This virtualization is giving you so much of independence and the power where you can increase your performance or decrease your performance as and when required. Today you have 10,000 users, so you have 100 servers, enough for that. Tomorrow you have 10,000 more users, you can add another 100 server without any much hassle because everything is virtual. 10,000 gone, cut down the 100 servers, you are running 100 again. So the flexibility or the scalability becomes so flexible. Okay, so clustering refers to the technique of grouping redundant resources so they appear as single device to rest of the network. That is clustering. Means you are using facebook.com, but you don't know how many servers are running. So it appears as a one service, but there may be thousands of resources or thousands of servers running behind that. Okay, so the web client directs the request to a single virtual address that represents the entire cluster. So you are using www.facebook.com and the server sends a response back to you, but you never come to know that how many servers are running behind. Because all the servers, they are running on one virtual IP address. So every time you have a server in your cluster, these are my servers in my cluster. Every server has two IP address, a physical IP address and a virtual IP address. Now every server has a different physical IP address, but all of them are having same virtual IP address. So if my request goes, this is my request, so there is a load balancer here. Now load balancer will decide, because the request comes for the virtual IP address, load balancer is going to hold that virtual IP address. It's not that cluster. So the load balancer will decide which server is available right now to handle this new request. Okay, this server has 10 requests, this server has 11, this server has 9, this is at 5. So which server is least busy out of all these? Okay, this server is least busy, go there. That server will handle the request of new customer.
Is there virtual ports? There's only a certain number of ports, right? Like physical ports.
So
Yeah, virtual ports.
here the physical, let's say this is physical, but the communication is happening between the load balancer and the server. Customer is only interacting with this load balancing device. Customer is never interacts with this server or any of these servers directly. Okay. Customer not going to act directly from any of the server, only with the load balancing device, only with an IP address. So two web servers work together in a cluster to host a single website. So they appear as one, but physically they are multiple. Physically they are, if I say, right? So there are multiple, physically they are multiple, but for the customer it's just one service. Okay, what is the group of redundant links called in Windows? Nick theming. Okay. Hypervisor. This is what virtualization is. Okay. So virtualization is basically introduced long time back, somewhere in 70s. It was introduced by IBM, and even we were using many times. So for example, I was giving you an example of this port. One network connection in my computer, in my phone, we can multiply the usage of that network connection from a very long time. But the virtualization comes to my computer much lately, somewhere in last to last decade, it came into our computers. So virtualization is a virtual or logical version of something rather than the actual or physical version. For example, your credit card, you have a 10,000 limit. Is that your money? No, but you have that money. So it's a virtual money. It's a virtual money. So which is virtual, not actual, or not present in a physical. So a host is a physical computer hosting a virtual machine, and a guest is each virtual machine. So we always have a concept of a host machine which has all the hardware, and then on top of it we are using multiple virtual machines, VMs. In short, we are calling them VMs. Now there are two types of hosts possible. One is called, on top of the host or this hardware, what I need on top of the hardware. Can anybody tell me? In order to use the computer, what I need on top of the hardware? Very difficult question.
Interface?
Very
OS.
difficult. OS. Yes, come on. It's just OS. Right? So on top of the hardware we need operating system and OS. So in the virtualization we have two types of OS, and in virtualization we are actually calling it hypervisor. So one is called type 1 hypervisor. Type 1 hypervisor, where the OS itself is working as a virtualization software. So OS itself is a virtualization software, and on top of it we can create virtual machines. With the help of this OS we can create virtual machines. What hypervisor, so this is one example of, so this is your type 1 hypervisor. In another example we have type 2 hypervisor. Let me take another pen. In the type 2 hypervisor, this is your host, this is your hardware, that is your operating system. Then you have virtualization application, and then or rather I would say, the virtualization application is running on this OS, and here you are creating virtual machines. Here you are using other applications such as MS Office, browser, and everything else. Now the difference between these two architectures, in this OS is not capable of or not doing any other operation except virtualization. Operating system is only doing the virtualization work. Here virtualization is a separate application running on top of the operating system, whereas you are also able to do or use this operating system for other applications. So it is like you can install this application on your computer, and you can also use your computer without this. Here you are using this OS virtualization operating system on top of the hardware, and then you create virtual machines on it, and multiple virtual machines can be created which can be used by the users remotely, In this case, these virtual machines can only be used by this computer. These virtual machines can only be used by the user of this computer. There is no other application of these virtual machines could be possible, or generally we do not. Here, in this case, these virtual machines can be your servers. Here we can use these virtual machines only for some learning purpose, learning operations, some testing operations, not production. These virtual machines can be used for production, can be used in mission critical applications. The type 1 hypervisor installed on a computer before any OS, or you can say before any OS is installed, and that is also known as bare metal hypervisor. Type 2, it's installed as an application on top of the operating system, such as the example of these is VMware, Microsoft Hyper-V, and I forget the name of Linux-based, though it is Linux-based, but Red Hat Linux has its own hypervisors. Here we have VirtualBox. We have VMware client, and we have Microsoft Virtual Machine. These are some applications we are using on Windows or on Linux operating systems. Now what I can do on these virtual machines? So we can install operating systems on these virtual machines. Multiple operating systems can be installed, or different operating systems can be installed on these virtual machines. What is the benefit of this? What is the benefit of using all this virtualization? So the benefit is reducing the hardware cost. In order to run four machines, I need 4 servers, 4 physical servers. But in this case, I can run all of them on one server. I can increase the redundancy by using this kind of architecture. I can increase the redundancy. I can increase the scalability. Because of this, I do not need a physical server to add more virtual machines. I can add more virtual machines without adding a physical server here. Security can be improved by using virtual machines because I need to protect only one server. I don't need to protect multiple servers. So a lot of benefits, a lot of advantages are there by using virtual machines instead of using multiple hardwares. 5 minutes more and then we'll take a break. So hypervisors are basically 2 types. Type 1 hypervisors, which runs directly on the hardware. Type 2 hypervisors run as an application on top of the operating system. So VMs, software and hardware characteristics are assigned when it is created in the hypervisor. So you can customize the following: a guest OS, amount of memory, hard disk capacity, processor type, and other options. And there are many things around. I would suggest that you should study yourself about these virtual machines and hypervisors, because how many CPUs are there in your computer? One CPU in my computer. But you know what? This hypervisor will present this CPU, can be presented this CPU as 100 CPUs. How is that possible? So remember one thing, that mostly the CPUs have something called core. Have you heard about this term?
Yeah.
Core. Like i3. How many cores you heard about i3? How many cores you heard about? How many cores i3 has?
Two to four. I remember when dual core was current.
Okay. Classes. You see that? The 12th, 13th and 14th gen i3 has 4 core. 4 performance core and 0 efficient core. And how many threads? 8 threads. If you look at this, 8th, 9th and 10th generation has 4 cores, and some earlier models were having 2 cores. So these cores and threads are treated as core and then followed by thread. So these threads are treated as virtual CPU. These threads are treated as virtual CPUs by your hypervisor. So every thread can have multiple CPUs. Every CPU can have multiple threads, and in that case it can have multiple virtual CPUs. In the server, if you look at the server, if I say I9, how many cores are there in I9 14th gen?
24.
24 cores. And if, let's say, every core has 2 threads, every core has, let's say, I'm saying minimum 2 threads, then how many virtual CPUs? 48. 48 virtual CPUs. Let's say it has 4 threads, every core has 4 threads. 96. 96 virtual CPUs in one CPU. And your servers can have 2 to 4 CPUs at a time. 2 to 4 CPUs we can have in one server. One server motherboard can have 2 or 4 CPUs at a time. Then calculate how many virtual threads would be there. And if I say that you can combine, think about cluster now. Cluster can have 2 servers or 4 servers combined together. So one server has 96 virtual CPUs. Now you combine 4 servers together in one cluster, then how many virtual CPUs you can imagine. So that way we can increase the number of virtual CPUs, and that way your hypervisors can handle those CPUs. And not only that, every thread is capable of doing
Multitask.
multitask. So when it is doing multitask, then you can imagine what will be the situation. Okay? Some of you are quite busy in doing their work. I hear a lot of mouse clicks, keyboard type, tuck, 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 tick, tick. Anyways. Alright, let's take the break for 10 minutes and then we'll continue.